Atmospheric rivers are long, narrow bands of concentrated water vapor that produce major amounts of rainfall and snow and are responsible for up to half of California's annual precipitation. Atmospheric rivers begin in the warm waters of the Pacific, where water evaporates into the air. When this humid air meets a Pacific storm, the water vapor is concentrated and driven toward the coast, becoming a fire hose of precipitation. Once the atmospheric river reaches the coastal mountains and the inland Sierra, the collision squeezes additional rain and snow from the system. Atmospheric rivers can be beneficial, replenishing reservoirs and keeping us out of drought. But too many, too close together, can create flooding. Yuba Water Agency is working with partners at Scripps Institution of Oceanography's Center for Western Weather and Water Extremes to better understand atmospheric rivers in our region in order to improve weather forecasts and better manage our water resources. In fact, Yuba Water is designing a new second spillway at New Bullards Bar Dam and Reservoir to maximize the benefits of this improved weather forecasting. The Atmospheric River Control Spillway, or ARC Spillway for short, will improve the dam's operational flexibility, significantly reducing flood risk, enhancing dam safety, and strengthening the region's resilience to climate change. Bullards Bar has only one spillway currently, situated high in the dam. Because of that, when there is significant rainfall, we have to wait until the storm is upon us and much of the reservoir is filled before we can release large amounts of water. But by then, the river channel below is also filling because of the storm. Another challenge is that currently, the maximum water level for the reservoir is set by an inflexible, calendar-based approach. During storm seasons, we are required to keep the water level in the lake lower so that there is plenty of room to store potential runoff. That's the case regardless of how much rain falls, which often forces us to release water at the beginning of winter, even though the rest of the year may end up being dry. But by building the ARC Spillway, with gates 31.5 feet lower in elevation than the existing gates, and also implementing Forecast-Informed Reservoir Operations based on the atmospheric river research with Scripps, we will be able to use the forecast to determine how much runoff water we expect to flow into the reservoir in the days ahead, and then release water in advance of the oncoming storm, while the river channel below can handle the flows. We can then use the space in the reservoir to hold back flows when the storm is strongest. The ability to reduce the amount of water on a levee system during the peak of a big storm can significantly lower flood risk. The reduction in peak flows decreases the probability of reaching or surpassing levee flood stages, as well as the likelihood of overtopping levees. But perhaps more importantly, it reduces the likelihood of seepage significantly, and that is key to levee safety. In fact, most levee failures in California, including the two most recent floods in Yuba County in 1986 and 1997, have been caused by excessive seepage during an atmospheric river storm. Here's how reducing the amount of water on the levee helps. The higher the water level on a levee, the more hydrostatic force is putting pressure on the base of that levee. This is the same phenomenon that makes you feel pressure on your eardrums as you go deeper underwater. As you swim down to the bottom of a pool that's 4 feet deep, there's not much pressure. But when you swim down to the bottom of a pool that's 8 feet deep, you experience more hydrostatic pressure pushing on your body. That same type of pressure can push and wear on levees, and if seepage finds a weak spot in the levee, the hydrostatic pressure will push flows through and erode the interior of the levee, eventually causing it to fail. So if the water in the river is 30 feet deep, the pressure at the bottom is much greater than if the water is only 20 feet deep, and that pressure decreases as the water level gets lower. In fact, some of the levees in our area are among the tallest in the state, so there's a ton of pressure on them in a storm when the channel is filling up. And every foot that we decrease the water level can result in a dramatic reduction of the pressure on the levee. So, building the ARC Spillway and implementing Forecast-Informed Reservoir Operations at New Bullards Bar will lower the downstream water levels, which reduces the pressure on the levees and the probability of seepage, thereby decreasing flood risk and significantly improving public safety. Find out more about this important public safety project at yubawater.org.